Okay, we're going to go ahead and talk through this lesson. From your previous knowledge, you should know that a constant function is just a horizontal line, that the slope of a horizontal line is 0. The derivative of a constant function, remember a constant function is a horizontal line, the derivative tells you the slope of that, so the slope of a horizontal line is 0, so the derivative of a constant function is 0. When we scroll down here and we look at the next one, what is the derivative of our linear function? Well, you know that your derivative is slope, and the slope of a derivative function, or of a linear function, you know it's just m. So your derivative, f prime of x, is just m. Now, we have already found the derivative of y equals x squared, and that is 2x. We've also looked at in the past that if your function is x plus 1 over x, your derivative becomes 1 minus 1 over x squared. Based on that, hopefully you've been picking up on the pattern that really all we're doing here is taking our exponent right here, putting it down in front, and decreasing your exponent by 1. And so that's what we're doing for this one here. That even works for this one here, but if you look at your original function as an x to the first plus an x to the negative 1 and follow that pattern or rule, you'll be able to more easily see that yes, it still goes ahead and holds true. You put your exponent of 1 in front, decrease your exponent by 1, which is 0, plus put your exponent in front, decrease your exponent by 1, so you got to go down. So then you get your derivative to be just a 1 minus a 1 x to the negative 2, which once again is what we have up here when you write it without a negative exponent. When you look at the next one here, this is just what's going on in general. This is referred to as your power rule. Whenever you have your variable raised to the power to take the derivative, you just go ahead and put your exponent of n in front, decrease your exponent by 1. If you want to see the proof, here's the proof of the power rule. You can walk through it. We have to use the binomial expansion or binomial theorem to expand this right here. Goes back to algebra 2 for that binomial theorem if you want. So that's what we're doing to be able to expand this first part to get this here. Then it's just a matter of collecting like terms and simplifying and taking your limit. You can look through that if you want. So here we're just going ahead and we're taking our derivative for each one of these. Take your exponent of 12, put it in front, decrease your exponent by 1. This is your derivative. This is the function that tells you the slope anywhere along this one here. Similarly with these here. However, when you're dealing with something like your h of x, you want to first of all rewrite h of x so that x is no longer in the denominator. Write it with a negative 1 exponent. When you have it written with a negative 1 exponent, once again you're going to just follow the power rule. Put your exponent in front, decrease your exponent by 1. So here we have our derivative. When you're looking at f of z and want to take your derivative, you have a number in front. No, that's fine. Just kind of leave it there. Put your exponent down in front, which is your 4. Decrease your exponent by 1, comes down to 3. Then your 4 times your 7 that's now in front is your 28. So your derivative of f prime of z is 28z cubed. So go ahead and do the rest of the problems here if you can, and then come back to the video to watch the rest of them. So here, all we're doing is just using the power rule putting our exponent of 9 down in front. 9 times 40 or 5 is negative 45. Decrease your exponent by 1. Put your exponent in front. 5 times 7 is 35. Decrease your exponent by 1 to 4. Put your exponent of 2 in front. Times it by the 25. We get 50. Decrease your exponent by 1. Here we get a 76. And your exponent's 1. So when you decrease it, it becomes x to the 0, which is 1. Now, when you're looking at this, that just disappears because it's a constant. We don't use a power rule when we're dealing with a constant because pi is a number just squared multiplied by a number, so the derivative of a constant is 0. Over here, you take your exponent, put it down in front, multiply them together, you get this. Decrease your exponent by 1. Same idea here, but once again, our x to the 0 here is just 1. 1 times negative 5 is negative 5. Negative 5 is a constant, just like 7 is a constant. Derivatives of constants is 0. Here you're asked to find the slope of your graph at x equals 2. Well, your slope, once again, is your derivative. So you do your derivative of this when we get this here. We want to know our slope when x is 2. So all you have to do is just plug 2 in here for x. And that's what we're doing right here. You get 2 to the 4th, which is 16, times 5, we get 80. Find the equation of a tangent line. Well, to find an equation of a line, you need to know a point, and you need to know a slope. Well, your slope comes from your derivative. Your derivative of x squared is f prime of x equaling 2 to the x. Now, that's the formula that tells you your slope. It doesn't give you your slope initially until you actually take and plug in your x value of 2. When you plug in your x value of 2 here, or f prime of 2, and that's what we're dealing with over here, we get our slope to be 4. But also, in addition to having to have a slope, you need to have a point. Well, we have our x coordinate being 2. How do you figure out the y coordinate being 4? Well, all you do is you take your 2, plug it into your original function. 2 squared is 4. And so that's how we get our y coordinate being 4. We now have a point and we have our slope. Well, we should be able to use our point slope formula, which is given to us right here. So you go y minus the y coordinate of your point, which is 4, equals your slope, which is 4, times x minus the x coordinate of your point, and then typically you're going to go ahead and solve it for y.